Welcome to the Starting Point Project's live stream broadcast for November 2018. Glad you could join us again. And first thing we want to say, as usual, is when is our next show? It's going to be Tuesday, December 4th. So put that on your calendar again, invite other people to watch, and it's going to be a little different. We have a mystery guest. Woo! It's actually going to be very exciting. It'll be the first time we've actually had a guest on the show. We'll pull up another chair here, reset the cameras. And I'm not going to tell you who it is, otherwise it wouldn't be a mystery guest. But it's going to be something very exciting, something I've been looking forward to for a long time doing, to share with you who the person is and some background. So that's next month, December 4th. Tune in for that one. Also, again, mentioning our Grand Canyon tours. Our next one is May 30th through June 2nd. We've only got like 12 seats left on that tour, so if you're at all interested, contact us soon. Before the bus fills up, you can go right to our website, thestartingpointproject.com, which is where you are right now watching this broadcast. So get a hold of us. It's a great trip. And again, for those of you new to the broadcast, you're watching the video right now on our homepage, and right next to that, there are some fields there where you can type in a question, put in your name, first name, last initial, or whatever. And then you can put in your email address. The email address is only necessary if we don't get to your question during the show. We can get a hold of you. Otherwise, we don't have your contact information. And you can hit the submit button. We get it instantly. And we cover those when I'm done with the speaking portion of the show. Also, just below that, there's an archive section. In fact, just a few minutes ago, we got a question from Greg in Wisconsin wondering, like, how do I watch the previous shows? This is his first show. So you can scroll right down, see broadcast archives, click on that, and you'll see all the previous shows. I think we've done, I don't know, maybe 15 prior to this. And a few days after this one is complete, this one will appear there as well. So that's where you can watch previous shows. Another shout out, I've been doing those for a few shows now. First one has to do with a conference I spoke at last month, the Spyglass Conference. It was out in Colorado Springs, a beautiful hotel, the Antler Hotel. Just behind there is Pikes Peak, just a beautiful area. And the person I'm saying hi to is Chris. Chris was also one of the speakers out there. I've known Chris for a while, great guy. So I told him I'd say hi. He says he watches all the shows. And I'm also going to say hi to his daughter, Rachel. So hi, Rachel. I know she's watching as well. And just so you know, we are in the process of raising some funds to pay for your therapy, because I found out that you actually think I'm a good speaker. So we know you need some help there. So we're working on that. We'll get it to you really soon. But great seeing your dad at the conference. Great friend of mine now, and looking forward to future conferences as well. Another speaker at the conference was Josh McDowell. Some of you probably know that name. He wrote one of the most famous books is Evidence That Demands a Verdict. He had a great influence on me when I was younger, just getting into all this. Kind of devoured that book and learned a lot. I've read other things from him. This is the first chance, though, that I ever had to meet him in person, so it was great. Got to talk to him, had dinner with him. I think he's about 80 years old now, but he is still really feisty. He's fired up and going gangbusters, which is really encouraging to see. So I was actually able to share with him what his life had meant to me and how much it has built into the ministry that I have now. Before I left Colorado Springs, I went to Seven Falls. I don't know if I mentioned in the past, you know that I do Grand Canyon tours, but I was also asked to go on a special Grand Canyon tour and hike all the way down to the river and back up. And I've been working out for a long time, but I haven't been doing a lot of aerobic activities, so I'm trying to get in better shape for that. It's going to be in February, actually. So went to this park. I'd been there once before. Just beautiful there, but there's a lot of steps to walk on. Here's one shot looking from the top of one of the steps looking down. And then this one, as you see full screen off to the left there, you see the Seven Falls coming down the rocks, and there's stairs built into the side. You can walk up, you can see in the middle of the stairs going up, and on the right side a little bit closer. So I was going up and down those stairs. Some of them I went up and down twice to try to get in shape. Just a beautiful area. I just feel very blessed too to see some of these places as I travel and speak. One other shout out to someone, and this is going to be Jerry in Texas. Yes, Jerry. Jerry's a regular watcher of our show, has submitted a number of questions, and I've mentioned in the past that Jerry and I actually went to high school together here in Wisconsin. Now he's living in Texas, and guess what I found? I found a picture from my senior yearbook here of our jazz band, and when you look at it here, you'll see myself there and Jerry both in the jazz band. This is 38 years ago. That's kind of scary, but it was kind of fun. I'm sure Jerry's got a big smile on his face and looking at, oh, look at the hair. Everyone had mops back then. But I brought something else along that I think might be pretty interesting to everyone, especially Jerry. I got it behind the chair here. This is my trumpet. This is the same trumpet that I had in the jazz band 38 years ago. I still have it. I still play it once in a while, get it out at home. So Jerry, you might recognize this. You probably still have yours. Keep it up if you're not. But a lot of fun. So it's just cool having a lot of people watch from all over the world, and some people that I haven't seen in a long time. We're trying to see if we can schedule something, an engagement down in Jerry's area so I can see him in person again. So thanks for watching, Jerry, and submitting your questions. Now, previous series we did prior to the one that we're at the end of right now is we did a series 4 parts, major issues with evolution. I'm not going to go through the details again, but again, if you go to the archive section, you'll see all 4 of those. A lot of powerful information there. Tonight's topic, we are going to be doing part 3 of 3 for icons of evolution. Completed 2 of them. This will be the last one this evening. Now, here's a little caution here, wet paint. Why did I put that up? I just finished this PowerPoint literally a few minutes ago. I have not gone through it myself yet, so this is going to be new to me, which is going to be kind of exciting, keeps me on my toes. So you'll kind of be patient with me as I muddle through some of this, and hopefully there aren't any mistakes in it, but it's just really, really fresh stuff, because everything I put together for these programs is custom. I'm not just taking talks I've given somewhere else and repeating them. I'm literally putting them together, and sometimes at the very last minute, like this evening's show. And again, icons. An icon is a graphic representation of something. Like when you see a cross, you typically think about Christianity. The scales there, weighing, balance, justice system, and then Statue of Liberty. You think about the United States and freedom and people coming to our country. Those are very famous icons. So we're obviously looking at icons of evolution. And here's another humor break. I've been putting some cartoons in here. This is Great Moments in Paleontology, and another Far Side cartoon. It says, rocking the anthropological world, a second Lucy is discovered in southern Uganda. We will be talking about Lucy a little bit here this evening. I'm sure you're somewhat familiar with Lucy. This is kind of my kind of humor, so I thought that was kind of funny. Hopefully you do too. I also mentioned another guy, Dr. Jonathan Wells. He wrote 2 books, Icons of Evolution, Science or Myth, and then the second one, Zombie Science, More Icons of Evolution. I actually have this book with me. I brought it along. I have both of these books. I just brought one of them this evening, but it's a great book. It covers, most of what we've been covering in this series, and there's a lot of extra details and references. So I used part of this for these programs along with a bunch of other resources, but I would recommend it if you want to know even more about this particular topic. And a quote that I've given the 2 previous sessions, I just think it's really, really interesting, very intriguing. This is a Chinese scientist. He's an evolutionist. He said this, in China, we can criticize Darwin, but not the government. In America, you can criticize the government, but not Darwin. And to me, that's just fascinating that, over in China, you don't dare question the government. You get put in jail, but you can question Darwin all day long. It doesn't matter. Over here, you can trash the government, stomp on the flag, burn it, or whatever you want, but you don't dare question Darwin because we know that's a fact and you don't want to be a science denier. So just kind of the opposite of what we have here in this country, even though we like to think we have freedom. So part 1 of Icons of Evolution, we covered Darwin's tree of life that branches out into all the different life forms. We talked about the Miller-Urey experiment, that they were trying to simulate what the Earth was supposedly like billions of years ago, how life maybe started. We looked at the peppered moths, and it's supposedly one of the best evidences of how evolution works. We looked at the fossil horse series from Eohippus all the way to the modern horse and found out that even evolutionists know it didn't really happen that way. Then part 2, we looked at Haeckel's embryos, all this embryonic development, how they're supposedly simulating evolution through all these different life forms. We found out that that was fraudulently drawn. Then we have Archaeopteryx. It was supposed to be this missing link thing, but no, it's just an extinct bird, a fully formed bird. Homology, invertebrate limbs, similarities in these limb structures of these creatures is supposed to be evidence of evolution. We found out why that doesn't really count. And then Darwin's finches. We always see the finches with the different beaks, and supposedly evidence that he discovered that also supports evolution, when in essence it really doesn't. Tonight, the final part, part 3, we're going to be looking at ape to human icon. This is it is the most popular icon that's out there. We'll cover that. We'll look at bacterial resistance to antibiotics, whale evolution, and then vestigial organ. I'll explain what that is when we get there. So we're going to start out right away. Number 9, ape to human transition. Again, here's the very, very famous icon. You have an ape-like creature standing more and more upright to a modern human. Everybody has seen that. Here's the original drawing. This came from Rudolf Zallinger in 1965. This was actually a fold-out in a book from Time Nature Library called Early Man. So in the book, you could open it up and then unfold this diagram that he had drawn of the progression from an ape-like creature all the way up to modern man. That's where it got its start. Here's an interesting quote from a book called Bones of Contention by Marvin Lubenow. He said this parade has been one of the most successful tools ever used to promote human evolution. It constituted powerful visual proof for human evolution that even a small child could grasp. It was a masterpiece of Madison Avenue promotion. There were few social study classrooms and school library bulletin boards where this parade was not prominently displayed. Because of its graphic power, it is still indelibly etched into the minds of billions of people worldwide. What is ironic is the book even stated that the parade was fictitious, but not everyone read the book. What they did see was the distribution of the parade. And that's what happens. You see something, it becomes very powerful, even if you don't read the details. And I just thought of a simple analogy. When I go to work out, I see all the TV screens they have up in front of the elliptical machines and all that, so people can watch TV. They don't have the audio on. And I noticed all the news broadcasts, they have little statements streaming along the bottom. And a lot of people just see a couple brief statements streaming on the bottom. They don't hear any of the context or any of the audio, any commentary on it. But now they've just learned truth because they saw that, so they know that's true. Well, it's not necessarily true. It's just like someone's sitting on an airplane and the two people next to them are talking about eggs, and someone says, yeah, eggs are actually really bad for you. I wrote an article on it. Now this person who overheard the conversation, quote, knows eggs are bad for you. I didn't know that. I eat eggs all the time. And they start telling all their friends, yeah, I guess eggs are bad for you. Well, how do you know that? Well, I listened to someone and talked to someone else about it. They read this article, they did all this research, and yeah, I guess they're really bad. And so many of the other people stop eating eggs because now they, quote, know eggs are bad. Now, I'm not saying eggs are good or bad either way, but the point is you just hear something simply and you assume it's true. Well, all the people looking at this book and seeing this diagram, it must be true. It must be a fact of science. I mean, they got the picture. So all you need today now is that picture, and people know exactly what that means. Evolution's a fact. We know that we came from ape-like creatures, even though most people don't know the details behind it. And here's a biology textbook, Biology from Miller and Levine. It says, but all researchers agree on certain basic facts. We know, for example, that humans evolved from ancestors we share with other living primates, such as chimpanzees and apes. That's not true at all. Not all researchers agree on that. Even within the evolutionary community, they're arguing with each other and debating each other and disproving each other's ideas of what came first, what it evolved into, when it happened, how it happened. So that's not true at all. But again, the biology textbooks say, well, that's just a fact. I mean, everyone agrees on it. And here's another great resource for this particular topic, this particular icon of ape to human evolution, called Contested Bones, co-authored by Chris Roop and Dr. John Sanford, both good friends of mine. Dr. John Sanford from Cornell University. He started the group Logos Research Associates and asked me to be on the board with him, so we've been working together for a long time on that. And Chris Roop, I met a number of years ago. I was going to fly him out here to spend some time with him. He got real busy. He's out in California now getting his master's degree. We'll do that sometime in the future. But this book just came out this year. It's a great book. In fact, I have it with me as well. Contested Bones, very well written. There's tons of information, and it goes through basically all the contenders that are around today about the whole ape-man transition, and we'll be looking at some of that here in this particular presentation. We're going to be discussing two major categories and two approaches. The two categories are the Australopithecines and the Homo group. Australopithecines are basically ape-like creatures, and then the Homo, that's Latin for man or or human. So those are the two major categories. And then we'll look at two approaches that are out there. We call them lumpers and splitters. What is that? Well, when they're digging up bones, they either tend to want to lump them together, like, well, these different bones here, we really think they're the same kind of creature here, or other scientists are constantly wanting to split everything. Well, no, I know they look really similar, but we think this is a totally new group, really exciting, so they're constantly splitting into more and more groups. So you got people tend to lump them together because they're very similar, and others say, no, we see enough difference, we want this to be a new group, and it's more exciting maybe if you have a new group, and maybe you can even become famous if you put your name on the group. We're going to be looking at two types of examples here, classic examples and then current examples, and we will start out looking at a few classic examples. First one is Nebraska Man. This is Australopithecus Cookii. They always give them these big elaborate names and make them sound like, wow, you know, these scientists are so smart, you can't argue with that. Well, it just means ape of the Western world, and it was discovered by a guy named Harold Cook. So it's Australopithecus Cookii. But you can see from the diagram there, it looks very much like an ape man. You got the longer hair, brutish face, standing upright like a human, but a little bit stooped over. He's got a club in his hand. He's got a wife behind him. She's making a fire. And in the back, a little bit harder to see, but there's some camels up top and there's some horses, so there's domesticated animals back there. They were able to determine an awful lot about this Nebraska man. It's pretty impressive. Okay, what was the evidence? Well, the evidence was found in Nebraska. That's why the common name is Nebraska Man. Okay, what was that evidence that allowed them to figure out all those details? It was one bone, and it was a tooth. Either that or a pair of compression shorts, I'm not sure which. I think it's a tooth. Just a single tooth here. How do you take a single tooth and make a whole ape man out of it? How would you know what kind of hair he had, what his face was like, if he knew about Stone Age tools and domesticated animals and fire and all that? You wouldn't know any of that. But they wanted it to be an ape man, so they made it into an ape man. Later they found more of these teeth. It turned out it came from a pig. So they took a single pig's tooth and made a whole ape man out of it because that's what they wanted. Now they realize, okay, that's not really an ape man. That one's gone by the wayside, so you won't see that in the textbooks anymore. Then we have Piltdown Man. This is the Anthropus dawsoni. This is Dawn Man. Dawson is a man who discovered it, so that's why they called it this. There's basically two portions of a skull here. The bones on the back of the skull looked very human-like, but some of the bones they found that were part of the jaw, and the darker color up there, the ones they actually found, the ones from the jaw looked more like from an ape. So there you have it. There's an ape man. It looks a little bit like human. It looks a little bit like an ape. So there's your ape man. Well, what it turned out to be was a fraud. The guy who discovered it knew it came from two different skeletons, but said, no, I found it on the same skeleton. And this was in the textbooks for over 40 years, being presented as evidence of evolution. And now they know it's a fraud. What happened was the guy who discovered it, he actually filed some of the teeth down to make them look more human. And he discolored the bones to make them look older. You know, some evolutionists will say, well, no, this is a perfect example of how science is self-correcting. That's how science works. Yeah, science should be self-correcting, and often it is, but this is actually a poor example because it took 40 years, world's leading experts doing research on these bones and getting PhDs writing their thesis on this example, and they didn't see the file marks in there, which later when that was pointed out, I was like, oh yeah, you could see the file marks there. They didn't want to see those things. And so this is not a good example of science being self-correcting. This is an example of people wanting to have evidence when it really wasn't there. Those are two classic examples. Next, we're going to look at more current examples, things that you'll see in the textbooks that they're saying, well, no, this is currently good evidence for evolution. And the first one is actually Neanderthal Man, which is also actually a classic example, but it's still around, so it's current as well. The bones are discovered in 1856. This picture was drawn in 1909. They called it Homo neanderthalensis, gave it its own category here. Looks very much like a gorilla, except it's standing more upright like a human, and it's got a club in its hand, so it's more intelligent than just a gorilla. Well, they've got a lot more evidence for this now, and they've updated it quite a bit. But here was a title that was on top there. It said, an ancestor, the man of 20,000 years ago. Now, they've even changed the dates on that too, but they were saying this is what mankind looked like 20,000 years ago. Well, because of much better evidence and being a little more honest about things, they've got different depictions in different museums. They look, different in each museum, but these depictions look a lot more human than that gorilla did, and they've reclassified them as Homo sapiens neanderthalensis. We are Homo sapiens sapiens. They're saying this is Homo sapiens neanderthalensis. Basically fully human, just another subgroup of human beings, another group that existed in the past that were fully human. So we take a look at this. We currently have about 500 skeletons of Neanderthal people. They lived right alongside of modern humans, anatomically modern humans. We have evidence of them living at the same time, right alongside. And they show great signs of intelligence. This is a short list. The full list is much longer. They have controlled use of fire, symbolic communication, artwork and sculptures, sewing and jewelry, musical instruments, and ceremonial burial of their dead. These were not brutish ape-like creatures. These were fully formed human beings, and there's so much evidence for that. Then we also have Neanderthal DNA in modern populations today. Europeans and Asians have 1 to 4% Neanderthal DNA in them, meaning in their past they had cohabitated, interbred with the Neanderthals, which means that they must have been human. If they weren't human, they couldn't have had offspring together. So we actually have Neanderthal DNA in people living today. Then we look at Neanderthal DNA versus modern DNA. They say it's 99.7 to 100% identical. Basically fully human. There's no genetic argument that Neanderthals are anything other than fully human beings. And then we have Neanderthal features that are appearing in modern humans today. Here's a picture of Nikolai Valuev. He was a former world champion boxer. Now he's a Russian congressman. He looks a little different. He's got different physical features, especially to his skull. He has a very sloped, forehead there, much like a Neanderthal would be. Nobody would say that this guy isn't fully human, even though looks a little bit out of the ordinary. And then we have another depiction here of Neanderthal Man in the museums there. They make it look kind of brutish, like that's Neanderthal Man, very different than we are today. Well, here's two pictures of modern people living today. These are Aborigines, and they're a little bit outside of the norm with different facial features, but nobody would say they're not 100% human beings. And yet, when we talk about Neanderthal Man, we want people to think, oh, he's very brutish and we evolved from them. No, they were fully human beings, just a different subset of humans that some of them lived, just after the ice age, or just after the flood during the ice age, and they had some different features and all that, but they were fully 100% human. And when you look at the skeletons look almost identical here. The Neanderthal on the left and the human on the right there, they're very similar. So again, there's no support from the fossil record or genetics that they were anything but fully human. Then we have paleoanthropologist Clive Finlayson. He's an evolutionist. He said this: the irony is that the scientific community is going to have to come around to the acceptance that the Denisovans and the Neanderthals also belong to the species which we call Homo sapiens. So here's an evolutionist saying, we got to admit it. The Neanderthals, they belong to us. They're human beings, Homo sapiens, and nothing short of that at all. Next example we'll take a look at, we call Lucy. This is Australopithecus afarensis. That just means southern ape from the Afar region of Africa. Why do they call it Lucy? Well, the first one they discovered, Donald Johanson, when they were digging around and they dug up the bones, they were listening to Beatles music, and the song they were listening to was Lucy in the Sky with Diamonds, so they call this one Lucy. A little bit of free trivia for you. I won't charge you for that one. It's kind of fun. My daughter gets a kick out of saying Australopithecus afarensis. She's memorized that and impresses people with that. She's actually paid attention to a lot of things I've shared over the years, and just really proud of her, how much she's taken this on personally, even though she told me just to razz me years ago. She goes, I don't really listen to you when I'm there in the audience, which is kind of funny. But here are the bones on the left there that they initially discovered with Lucy, and then here's the depiction in the museum standing upright on the right there. And here's some more of the details. Discovered in 1974 by Donald Johanson. They found 40% of the skeleton, claimed it was 3.5 million years old, and then they purported that it walked upright, more like a human being. So here's Lucy again on the left there. Looks very much like a chimpanzee, except she's standing more upright. Well, let's take a look at the feet here. We could look at the feet and the hands, and just with the time I have, I didn't have time to look at the hands. If you want to look towards the top, you can see the hands. The hands look very much like human hands, but the feet too. The feet look a lot more like human feet than they do like ape feet. The offset there I have just to the right there, that's an ape foot, but the feet they have on Lucy are more like human feet. Why did they put that on Lucy? When they found the bones for Lucy, they didn't find the foot bones or the hand bones. So why did they do this? Here's why. About 1,000 miles away, they found a series of human-like footprints. They looked identical to human footprints. Why is that a problem? That's a problem because if humans were already around leaving those footprints at the same time Lucy was around, then Lucy is obviously not on her way turning into a modern human because modern humans already existed. So that's a problem for them. So what did they say? They said, Lucy must have had human-like feet. So they put human-like feet on Lucy in the museums and say she left those footprints. Well, since we've discovered this first fossil, we've discovered many others, and we found the foot bones and the hand bones, and they're long and curved just like a chimpanzee, but they usually don't bother to update the museums because that would ruin a good story that they've got going. But here's a quote, "Make no mistake about it, they are like modern human footprints." Paleoanthropologist Donald Johanson. Well, who's he? Oh yeah, he's the guy who discovered Lucy to begin with, and he's a big-time evolutionist, and he's saying those footprints, they're identical. In fact, other quotes go on to say, if anyone saw them today on the beach, they would say they're human footprints. They're indistinguishable from human footprints. More about Lucy. Johanson initially claimed that he found human bones alongside the Australopithecus bones, the Lucy bone. Later, under pressure, changed his story and claimed that they were all Australopithecus afarensis. So what was going on there? When he first found Lucy, he was finding other bones, and he's like, well, yeah, I'm finding human bones too. Someone else said, well, wait a minute, you can't say those are human bones because if humans already existed, then Lucy's not on her way evolving into one. So he's like, okay, well, no, those other bones weren't human. They were like ape-like, so he changed his story, even though when he was more honest, he was saying, no, those other bones, they're just human bones. Next example, Australopithecus Sediba. We'll be a little bit shorter with this one. Here's an interesting quote from Josh Fishman, senior editor at Scientific American. He said, the birth of our genus has long been a conundrum for paleoanthropologists, to say the least. Only a few scattered fragmentary fossils older than 2 million years have been argued to belong to the genus. So he's initially saying here, this has kind of been confusing figuring out how we've evolved because, 2 million years old on out, we just don't really have much of anything to go with. And here's one other quote along the same lines. This is William Kimball, director of the Institute of Human Origins, Arizona State University. He said there are only a handful of specimens. You could put them all into a small shoebox and still have room for a good pair of shoes. I think that's kind of a clever quote there, but he's saying we don't have a whole lot to go on when we're looking at 2 million years on out. How do we get from an ape-like creature to a modern human? So, taking a look at some of these details, Sediba was discovered in Africa in 2008, kind of by accident. And then they found about 50% of the skeleton, claimed it was 1.97 million years old by dating the layer that was just under it. And they said it may be the best candidate yet for the intermediate answers of our genus. Again, trying to figure out how do you get from an ape-like creature all the way to a modern human. They said this is probably the best candidate now that we've discovered, which Lucy used to be, and that makes Donald Johanson upset. He used to be the front runner, but now they're saying this one. So he's got a lot of arguments why this one doesn't count at all himself. But cutting to the chase because of time and all that, this was just a mixture of Australopithecine bones and human bones. So they found a little bit of each, and so some of the bones look more like apes, some of the bones look more like humans. So that's why they were saying, oh, this is evidence of ape men that lived back then. No, some were just apes that were around, some were just humans that were around. So it's really not evidence of an ape man at all. Here's another quote, paleoanthropologist John Hawks from University of Wisconsin-Madison, about an hour from where I live here. He said, it's not everything the rumor mill said it was going to be. It's not a missing link. So again, an evolutionist saying, okay, Sediba, no, it's not a missing link. They wanted it to be, but he's at least being honest. it really doesn't qualify. Last one here, Homo naledi. I was going to put together more on this one, but again, it's the same story basically along the way. Cutting to the chase on this one, Homo naledi is basically fully human. When you look at all the details, it just kind of screams fully human, fully human, fully human. There's nothing transitional about it. Again, if you want more details on that, you can get that book, Contested Bones, that we referred to earlier in the program. So the conclusion with the ape men is this. Here's a quote from Bernard Wood, British geologist from Oxford. I was there earlier this year speaking in Oxford. It's kind of neat, but here's what he had to say. Even with all the fossil evidence and analytical techniques from the past 50 years, a convincing hypothesis for the origin of Homo humans remains elusive. They're still basically looking for a strong case. They don't have one yet. He also said this. There's a popular image of human evolution that you'll find all over the place. On the left of the picture, there's an ape. On the right, a man. Between the two is a succession of figures that become ever more like humans. Goes on to say this. Our progress from apes to humans looks so smooth, so tidy. It's such a beguiling image that even the experts are loath to let it go. But it is an illusion. So again, there's an evolution saying that progression, that ape to man icon we've been talking about, it's an illusion. It did not happen that way. There's no evidence for that happening. But the icon will be continuing to use in textbooks and television shows, and all you need to do is show the picture. You don't need any evidence to say, and it's good enough for me. So wrapping up this topic of apes to humans, basically there are three categories that every evidence that's ever been discovered so far falls into, and any new one that comes up is going to fall into. Everything you ever see is going to be in one of these three categories. It was either fully ape that they tried to make look more human-like, and that would be Lucy. Lucy's basically an extinct chimpanzee-like creature they tried to make look more human. Or it was really fully human that they tried to make look more ape-like, and that would be Neandertal Man. Fully human, but they wanted you to see him as being more of a brute that we've developed from. Third category is a mix of the two. Piltdown Man's a good example of that, a fraud in that case of some ape bones and human bones put together. So every single one in the past and all the future ones are going to fall into one of those three categories. So we've seen it here that this icon, ape to man, just doesn't cut it. Number 10 here, antibiotic resistance. This one might take some explaining. Many people aren't as familiar with this particular one, and has to do with antibiotic resistance in bacteria. Bacteria can become resistant to antibiotics, and so I will explain how this one works. And they tell us that this is actually evidence of evolution right before your eyes. You can see it. They will usually admit, evolution happens so slowly you're not going to see it. If you could live for millions of years, you'd be able to observe it, but we don't live long enough to actually see it happen because it happens so slow over millions of years. But this, they say, is an example of where you can see it basically right before your eyes. And this is basically how it's taught in the school system. Let's say there's a young girl, let's say she's 5 years old, and she gets sick, really sick. So parents take her to the doctor. The doctor says, oh, you've got this strain of bad bacteria that's going around, it's an infection. We've got an antibiotic for that, we'll give her a shot. So they give her a shot, she goes back home, and she starts to feel much better. But then maybe within a week later, she starts to get sick again. So the parents take her back to the doctor. The doctor says, oh, that's okay, we'll just give her another shot, she'll be fine. So they give her a shot, but this time she's not feeling better. She's still sick, so they do some further research, and they've discovered that her bacteria have evolved resistance to the antibiotic in a short period of time. And here's the point with this. If that much evolution, a little evolution could happen in a very short period of time, imagine what could happen over millions and millions and millions and millions of years. That seems to make a lot of sense, doesn't it? I mean, small changes here in a short period of time. Imagine what could happen over a much, much longer period of time. Well, we're going to do now what Paul Harvey, a famous radio announcer, was famous for. He was famous for telling people the rest of the story, and we're going to take a look at the rest of the story of what's actually going on here. Well, here's a story talking about antibiotic resistance in bacteria. This is kind of how it works. Let's say you've got a bacteria that's bad. We've got a lot of bacteria in our body. Most of it's good, but sometimes the bacteria is bad and we want to get rid of it, so we create an antibiotic to get rid of these bad bacteria. So we inject it into our bodies. These bad bacteria see it as being something that's good food. They absorb it through their membrane and then they digest it. It's lunchtime for them. So they do that, but when they digest it, it gets converted into a poison, and then that actually kills them. That's how antibiotics work. They take it in as food, it gets converted to a poison, and they die. So they're gone. Well, here's what can happen. You've got millions and millions and millions and millions of bacteria in your body, including a number of bad bacteria. As these bacteria, we're focusing on the bad ones right now, as they reproduce, there's a lot of them, mutations are happening. We've talked about mutations in the past. These are accidental copying errors in the DNA. In some of these copying errors, it destroys the information that makes the enzyme that would break down that antibiotic. It helps kind of chew their food. So what happens to these bacteria? Well, the antibiotic comes in, but they're not breaking it down now to convert it into a poison. So they survive. All the other ones that aren't mutants, they die out. But these mutant ones survive because they can't break the antibiotic down into a poison. And then they reproduce. These mutant guys reproduce. They're copying this mistake. So now all these bacteria that are their offspring, they also cannot break down that antibiotic. So now the antibiotic comes into the environment, and these mutant guys survive because they can't break that thing down. So did these bacteria become resistant to the antibiotic? Yes, they did. Is that a change? Yes, it is. Was it a benefit to them? Yeah, it was very beneficial to them. They survived. But here's the key point. They became resistant due to a loss of genetic information. They lost the genetic information in their DNA that produces that enzyme that helps them digest their food. They're not as healthy as a normal bacteria, but they can survive when there's an antibiotic around. The problem is when there's no antibiotic, which is most of the time, other bacteria that have survived will outcompete them, and they're headed downhill. If that process continues, they're going to be wiped out and extinct. They're not gaining new information to fight the antibiotic. They're going the wrong direction. So it is an example of change. It is an example of being a benefit, but it's never going to produce new things. You're not going to produce eyes and wings and spleens and things like that by this process. So it's a real, factual, biological process, but it's actually going the opposite direction of evolution. It's not an evidence for evolution. It's going the wrong way. So antibiotic resistance in bacteria, even though it's an icon of evolution, that one doesn't cut it either. Next one, whale evolution. This one's, you might not think of it's a big deal, but it's in a lot of textbooks and it's touted quite a bit recently. So we'll take a look at whale evolution. I've had a chance to be out in the ocean a number of times and see whales come and breach, sometimes full breaches. It's just amazing to see those creatures come out of the water. So we're going to talk about their evolution. Here's another cartoon. It says, how are we ever going to evolve if you people keep pushing us back into the ocean? It's kind of funny there. He's trying to get out to evolve into something else, and they're trying to save him, push him back. There's another little creature in the bottom right-hand corner. He's walking out, and he's going to evolve apparently. So, I appreciate good humor, even if it's supporting evolution somehow. The funny thing about this is just the opposite of what they think the story of whales are. Whales actually started on land and went into the ocean. This cartoon's talking about whales coming out of the ocean, trying to get back up onto land again. And maybe he's coming back because he forgot his cell phone. I'm not really quite sure there, but we'll approach this a little more seriously. Here's an interesting quote from Stephen Jay Gould. He was one of the world's leading evolutionists. He was from Harvard. He said, the embarrassment of past absence of cetacean transitions, talking about these whales and things like that, has been replaced by a bounty of new evidence and by the sweetest series of transitional fossils an evolutionist could ever hope to find. Truly, we have met the enemy, and he is now ours. Moreover, to add blessed insult to the creationist injury, these discoveries have arrived in a gradual and sequential fashion, a little bit at a time, step by step, from a tentative hint 15 years ago to a remarkable smoking gun in early 1994. So he's admitting, he's saying, yeah, we've struggled in the past to try to find some of these transitional forms, and the creationists were always on us for that, but man, do we have them now. We have a smoking gun, and we can put them in their place because of this series and evidence for whale evolution. He also went on to say this sequential discovery of picture-perfect intermediacy in the evolution of whales stands as a triumph in the history of paleontology. I cannot imagine a better tale for popular presentation of science or a more satisfying and intellectually based popular victory over lingering creationist opposition. So this guy has an axe to grind. He's no friend of creationists, and he's really happy now that he's got this fantastic evidence. He can't imagine better evidence to put us in our place. So that's kind of where he's coming from with that quote. Here's a visual pictorial of how evolution supposedly worked from Smithsonian. We start out on the left side there with fish. The blue here on their picture is the water, lakes, oceans, whatever. So the fish eventually started to evolve as an amphibian. It's coming up out of the water and evolves into a fully formed mammal. But then the mammal starts to kind of head back towards the water again and eventually evolves into something like a whale, which spends all of its time in the ocean there. So that's how they believe evolution occurred. Here's a quote from Smithsonian. It said, vertebrates evolved in the sea and eventually moved on to land. The ancestors of whales later returned to the sea, taking advantage of its rich food supplies. Now, before I finish this quote, talking about rich food supplies, I thought about this package of M&Ms. My wife has given me a hard time trying to get me to eat better. She's actually been pretty successful, but thought I had her one day. I was looking at a package of M&Ms and I saw the back of it. And I showed this to her on the back. I said, look, it says nutrition facts. If there wasn't any nutrition, they couldn't have nutrition facts. She didn't really buy that, so I don't really get to eat M&Ms much anymore. But anyway, I just thought about that when it said rich food supplies. But getting back to our quote here at the bottom where we're finishing up in the white, it says, as early whales adapted to their new marine surroundings, a diversity of species evolved. As they adapted to their new surroundings. How did they survive when they weren't adapted yet? They're in the water and all that. That's a big question. We'll see that that's a problem as we get into this a little bit further. Here's a diagram from Berkeley. You don't have to worry about all the details on here. There are lots of diagrams of whale evolution. The one thing I'm going to point out here is on these little branches here, the nodes where they branch off, they almost never have a picture of a creature where it branches off. Like what creature actually split into 2 lines or 3 lines or whatever. They will have creatures kind of on the end of the branches, but not where those nodes are. That's very common no matter what kind of evolution that they're talking about. Here's a quote from the Public Broadcasting System. It said, call it an unfinished story, but with a plot that's a grabber. It's a tale of an ancient land mammal making its way back to the sea, becoming the forerunner of today's whales. In doing so, it lost its legs, and all of its vital systems became adapted to a marine existence. The reverse of what happened millions of years previously when the first animals crawled out of the sea onto the land. Well, again, it sounds so passionate and dynamic, and what a beautiful story of how the whales, from a mammal returned to the sea. It's so beautiful. It's like, okay, how it lost its legs. That doesn't sound like a good thing, and it's going the opposite direction of what evolution should produce. And then all of its vital systems became adapted to the marine existence, to living in water. How did it survive when all of its vital systems were not yet adapted to being in that marine environment? And where do we see those transitions? We really don't. But again, nice storytelling here, and we'll look at this further. They say some details remain fuzzy and under investigation. Yeah, I guess so. But we know for certain that this back to the water evolution did occur thanks to a profusion of intermediate fossils that have been uncovered over the past 2 decades. All right, so it's very confusing, but thanks to these fossils we found, it really clears up a lot of stuff, and the fossils are what tell us we know it's an absolute fact. So here's another quote from phys.org. It says, did you know that all marine mammals descended from common land-dwelling ancestors? It might be difficult to see that by looking at modern species alone, but that's where the fossil record comes in handy. An accurate picture of their evolution is crucial for helping us to understand the structure of increasingly threatened aquatic ecosystems. By looking in detail at the fossilized ancestors of marine mammals, we can see that terrestrial mammals returned to the seas millions of years ago. This makes them secondarily aquatic. A major part of this involved the morphological and behavioral adaptations required to become specialized ocean feeders. Anyone who's ever tried to eat underwater will know exactly what we mean. Yeah, I'll bet. I mean, we've all tried to eat underwater, haven't we? And that's pretty difficult. That's kind of bizarre. I don't know who's actually tried to eat underwater, but that would be kind of impossible. But these creatures somehow, over millions of years, learned how to eat underwater. What did they do before then? I'm not quite sure. They go on to say, this is important as it shows us how using the fossil record opens up the process of evolution as opposed to just looking at a product of its by focusing exclusively on modern animals. Lesson, don't try to understand evolution without looking at the fossil record. Again, these are their words. You got to look at the fossil record. Otherwise, you're going to be confused. You're not going to see the evidence, but the fossil record is really what does it for them. So we'll look at some of the primary suspects here for whale evolution. There's a number of them on here. We're not going to go through each one. I'm just going to pick out some of the more pertinent ones. We have Pakicetus, Ambulocetus, and Rhodocetus. We'll start out looking at Pakicetus. Pakicetus, cetus just means whale. It's Pakicetus because it came from Pakistan, so Pakicetus, again, cetus meaning whale. I actually went to a restaurant once and they said they could see us right away. I think we just lost our audience. No, and it's just a bad joke. Normally I don't go that low, but I couldn't help myself there. But anyway, they found some bones here, and they called it Pakicetus, and then they drew this picture of what it supposedly looked like. So it's this kind of mammal-like creature heading back in the ocean, swimming around, and feeding on fish. So they were pretty creative with their drawing. Well, here's a quote from an evolutionist from the University of Michigan, Ann Arbor. He said, in time and its morphology, Pakicetus is perfectly intermediate, a missing link between earlier land mammals and later full-fledged whales. So this is a perfect intermediate from land mammals to whales. I just thought of this. I didn't have time to find the picture, but years ago, they actually, in some textbooks, had a picture of a cow wandering closer and closer to the oceans, telling people that cows spent more and more time in their water and eventually turned into whales. Well, there's no evidence for that, so they've kind of changed their story. But this guy here is saying this is a perfect intermediate between land mammals and whales. Well, here's the fossil again. The colored bones there are the only ones that they actually found here. Well, since they discovered this, they found basically the rest of the skeleton, and it's much more like this. And now they think, well, okay, it wasn't really like that drawing we came up with. It's more of this mammal here. It has nothing to do really with whale evolution, but they had a great deal of artistic license as they were discussing this. But you find more of the bones and oops. But wait a minute, that was the perfect intermediate, and now that one's not really cutting it. So Pakicetus, we could scratch that one off, and now we'll look at Ambulocetus. That one will be next here. This is what they told us Ambulocetus looked like, so we'll discuss this one very briefly. Two skeletons on the screen there. The top one is what they envisioned it would look like if they had all the bones. The bottom shows you the actual bones they found. The bones in red were actually found, I think, about 15 feet above the rest of the skeletons, or may not have belonged to this particular skeleton, but use their imagination as to what this thing actually looked like. The key piece here that got them to think this must be an intermediate becoming a whale was because of the ear bone. But the guy who actually discovered it, I saw the video, he says, well, actually the ear is really questionable. Well, if that's like your strongest piece of evidence and you're saying it's really questionable, then this is not powerful evidence of an intermediate mammal, becoming a whale. Here's another depiction from a museum. On the top of the skull there, it's a little bit harder to see, but they have a blowhole up there because obviously whales have blowholes, so the mammal had to develop that. So they have the blowhole at the top of the skull there. Here's another angle. You can see it a little bit clearer there. Well, guess what? The skull actually didn't have a blowhole there, but they put it in the museum because they want you to get the impression that this thing is evolving into a whale. And so, hey, here's a blowhole that had moved from the end of the nose up to the top of the head and all that. And there's a lot of problems with that, but it's actually, I think, very, very deceptive. So Ambulocetus doesn't count for that and other reasons that we're skipping. Last one we'll take a look at is Rhodocetus. This is what they say Rhodocetus looked like. You can see a little bit like a mammal there, but then the tail, man, that really looks like a whale quite a bit with that fluke there. Well, here were the bones that they discovered. They didn't discover any bones in the tail or fluke or anything like that, and they gave it more like webbed feet. So they put the fluke on it because they wanted you to think it's, becoming a whale. So that a very powerful visual there that here's an intermediate. Again, they put more web-like feet on it, because it's going from just legs turning into a whale. Well, they've had to update their drawing. They still have some web things on the feet because they want you to think it's an intermediate. But they admitted, the guy who discovered it admitted, okay, no, there's no evidence it had a fluke tail. He goes, I don't think it had a fluke tail, so they had to put a regular tail on it again. They keep telling a lot of stories that try to get you to think that this is an intermediate form when it really doesn't count at all. So Rhodocetus, for those and a few other reasons, also is discounted, and it's just destroying their chain here of all these intermediates that they said they finally had. There are additional challenges, too, to turning a mammal into a whale. And we'll see some of that here in detail. First of all, you have to have collapsible ribs and lungs. Well, why would you need that? Some whales can dive up to 3,000 meters. That's about 1.9 miles. That's a lot of pressure. In fact, it's equivalent to about 300 times normal atmospheric pressure when you're diving that much. It would totally collapse your ribs and your lungs and you would be dead. You have to evolve that somehow. Again, how do you survive when your lungs are still the normal lungs and rib cages that you would have in a mammal? They would have been crushed and you would have died. How are they going to just slowly evolve over millions of years? And then we have the whole underwater eating thing that we mentioned before. Is how do you magically just evolve by accident, just making mistakes in your DNA? Slowly over time, you just accidentally evolve the ability to eat underwater. Then we have giving birth and nursing underwater. This is incredibly complex to be able to switch from being a mammal, giving birth on land, to actually doing that and nursing underwater. That is not going to happen through evolution. And then we have countercurrent heat exchangers that's got to be developed that whales have. We can't go to those details right now. And then developing blubber for temperature, insulation, there's a lot to that. The ability to drink seawater, which affects the kidneys. The kidneys would actually drive that, so they'd have to be evolving by accident all at the same time. And then new muscle systems for that blowhole. There's a lot there that's going on to be able to breathe through that without letting water get through when it shouldn't be getting through. The eyes modified for vision underwater. That's a huge change. That has to happen by accident through mutations. And then an echolocation and communication system that is very, very, very complex. There's no way that that's going to happen by accident. Then we have genetic relationships. These extinct groups of land-dwelling carnivores, that's what they initially envisioned, that evolved into a whale. Well, when they look at it genetically, whales are a lot more closely genetically related to hippos. But none of them think a hippo evolved into a whale. But when you look at genetics, the genetics are much closer there than anything else. So it's just not lining up with the bones. It's not lining up with genetics. So we see that the icon for whale evolution, that one doesn't cut it either. This last one here, vestigial organs, this one's going to go even quicker here. This one, again, might be one that you're not as familiar with, so we'll have to describe it. Charles Darwin, author of The Origin of Species in 1859, he said, on the view of descent with modification, that's kind of the whole idea of Darwinian evolution, we may conclude that the existence of organs in a rudimentary, imperfect, and useless condition, or quite aborted, far from presenting a strange difficulty, as they are assuredly due an ordinary doctrine of creation, might have been anticipated and can be accounted for by the laws of inheritance. Okay, what did he say? He just said, seeing these things inside of our bodies and other creatures that are kind of useless, that aren't doing anything, that would be a surprise to a creationist. Why would God design something with useless things in them? But it might be anticipated if evolution is true, because over time accidents happen and some things go out of use. That's what Darwin said back in 1859. Around his time, Robert Wiedersheim, he was a German anatomist, he had 86 examples of things inside our body that supposedly are vestigial, leftover, useless things from the process of evolution. Again, evidence against creation, because God wouldn't design you with all these useless things in your body. It was actually used at the Scopes monkey trial in 1925. Won't go through those details. Very, very interesting story. Got to fast forward. Up till 1981, textbooks were still talking about these vestigial organs. They had lists of about 100 things in our bodies that were useless. Again, proof of evolution. Here's a website, Understanding Evolution, from Berkeley, University of California. This is an article they had. It says, we've all got baggage, meaning leftover stuff in our body from evolution. Here's what we'll focus on in this article. It says, all life evolves, and so all life bears the scars of its history, including humans. Our awkward wisdom teeth and appendix are simply historical holdovers that evolution has not managed to rid us of. So they're saying, here's just some examples of stuff that's in our body, it's going away, it doesn't really do anything, and evolution will eventually get rid of it, but it's still here for now. Again, evidence of evolution. Oh, here's a quote from Jerry Coyne, one of the leading evolutionists. He said, we humans have many vestigial features proving that we evolved. The most popular is the appendix. Our appendix is simply the remnant of an organ that was critically important to our leaf-eating ancestors, but is of no real value to us. So here's the appendix. Well, guess what? The appendix does have a function. It's actually part of the immune system. So it's on the bottom here. That's your digestive system at the bottom here. That's actually the appendix. It's part of the immune system. Can you live without your appendix? Yes, you can. You can also live without your arms. That doesn't mean they don't have a use or a function. So it's part of the immune system, and scientists know that, doctors know that. They used to yank your appendix out. Sometimes they were doing other surgeries. They'd just take your appendix out because it's useless. That's what evolutionists told us. Well, now they know it's part of the immune system, so if you don't have to take it out, you leave it there. Now, if it's going to burst, you might want to get rid of it. But it was actually evolutionary beliefs that led to poor science. You just write it off. It's a leftover from evolution. The creationists would say, no, it must have a purpose. We might not know it yet, but it's designed by God, and now today we know it's part of the immune system. Another example, wisdom teeth. Oh yeah, that's a proof of evolution because the wisdom teeth are left over. We shouldn't even have them. They get in the way and all that. Sometimes it's a problem. They can become impacted or not enough room in your jaw for them to develop, but it has nothing to do with evolution. Most of the time you have enough space there, and dentists are very hesitant to take your wisdom teeth out unless, again, there's some problems with spacing and crowding and all that, but they have nothing to do with evolution. They have a purpose. Then we have the coccyx. It's the bone at the end of your spine there. It's called the tailbone. Evolutionists used to say, okay, this is left over from evolution. No, it performs a very important feature. It's a muscle attachment point. If you didn't have that, you couldn't sit up straight or do other bodily functions that we need. It is not a useless organism. It's not evidence of evolution. It was designed and has a purpose. Then we have the whale hip bone. We've talked about whales just a little bit here. There are some bones in the whale. They say these are left over from earlier stages of evolution when it was on land as a mammal. There was a pelvis and a femur. No, those aren't left over from evolution. Those are bones that are critical for the whale to reproduce, and scientists know that now. It has nothing to do with evolution. They do have a purpose, and they were designed that way. These are not useless organs. If they're not useless, they can't be evidence of evolution. Even if they have a diminished use, because now what evolutionists will say, okay, we're not saying they're completely useless all the time, but they either have a diminished use or they have a changed use, and that would be because of evolution. Well, just because a use might be diminished somehow wouldn't mean it's evidence of evolution. And again, it's going the wrong direction. It's going downhill rather than getting more and more useful. And even if it was changed in use, how do they know it's changed in use? They're assuming evolution is true, that some other creature that maybe we're related to has something similar that was used in a different way, and they're assuming in our bodies it came from that, but it's used differently now. Well, that you have to assume evolution is true to even make that connection, and that's not proof of evolution. It still has a use, and there's no evidence that it came from something else to begin with. And it really represents circular reasoning, and here's why. They say that vestigial organs are the result of evolution. The reason we have vestigial organs is because of the process of evolution. Then they will go on and say, one way that we know evolution is true is because of the existence of vestigial organs. So it's circular reasoning going on here. It has nothing to do with evolution, but it's used in many of the textbooks telling about all the stuff in our bodies that are useless and are left over from the process of evolution. So again, vestigial organs, the appendix, tonsils, and other things like that, no, they do have a purpose and they're not evidence of evolution at all. So we just went over four things, somewhat quickly here: ape to human, bacterial resistance, whale evolution, and vestigial organs. And we've seen that each one of those really does not provide evidence for evolution at all. So again, a reminder for next month. On December 4th, we're having our mystery guest. You'll want to tune in for that one. Guarantee it's going to be a good one, guarantee, or your money back. And again, December 4th is the date for that one. Please put that on your calendar. We are now going to be moving into our Q&A session. As usually, what we do is we take a brief, very, very brief break here, commercial break, and then we'll be right back with your questions. So we'll see you in a minute. All right, we are back, and I went on and on and on, and we went much longer than usual. I didn't have a chance to time this, so we got time for one question, and that question is going to be from Rachel in New York. Hey, Rachel, we appreciate you watching and glad that we were able to get to your question. Rachel asks, you frequently quote experts who disagree with so-called evidences for evolution. What happens professionally to these experts? Great question. There was a documentary that was actually out in the theater a number of years ago called Expelled, No Intelligence Allowed. I would highly recommend that everyone watch that. I'm sure you can get it on Netflix or your video store or wherever you get movies and documentaries. Very entertaining. It was not a documentary on creation. It was not a documentary bashing evolution. It was simply making the point that if you are in the scientific community and you publicly express any doubt, any serious doubt about evolution, you could lose your job. You probably won't get published anymore. You won't be able to earn a living. And they documented that so well. Very, very powerful documentary on this particular subject. So that's typically what happens. There are actually many, many scientists who doubt evolution, and a fair amount have actually said so, and many of them have paid the price. There are many, many more scientists who doubt evolution, but they don't dare say anything, and they're not going to because they appreciate their job too much, whether they're teaching or doing research. So privately they admit, yeah, I don't really buy into all this evolution stuff. The evidence just doesn't cut it. We know too much about genetics to believe in what we've been taught about evolution all along the way. But it doesn't pay for me to say anything because I don't want to lose my job. So, whether they're teaching or whatever they're doing. So they're safe as long as they don't say much about it, but if they do say something, and I've got a lot of examples of this happening to people. One was a teacher, a professor at a Christian college. She was teaching biology, and in that Christian college, they actually teach evolution. They were not allowing her to teach creation. They even told her, you are not even allowed to say the word creation in your class, which is just really sad. It's probably surprising a lot of you. But not only did they make sure that she had to teach evolution and couldn't even talk about creation, they started auditing her, and then they told her the next semester, you're not coming back. So she lost her job. So there she kind of spoke up, and she said, well, she did believe in creation, but she was willing. She was willing to teach evolution. Even though she didn't believe it, she was going to teach it because it was in the textbook. She agreed to that, but they let her go because she dared to voice her opinion. A lot of examples like that out there. So that's what can happen in many of these situations, whether they're researchers or teachers or whatever they're doing. If they speak out, they may have been a very prominent scientist, but all of a sudden they're ostracized and pushed off. Well, they weren't a real scientist, because if they were, they wouldn't have doubted evolution. So at first they're held up and prompted as like, well, they're an awesome person, but then they doubt evolution, so they obviously can't be a real scientist anymore. So it's unfortunate, but that happens quite a bit. Great question. We look forward to seeing everyone again next month, December 4th. Going to be a great program, mystery guests. Hope you tune in for that. God bless.